So most of the problem which helps you to get good score. So those are, I mean, given and attend some answer like that. I mean, if you have a sufficient hold, you can do. Okay, some problem you may need more way of thinking. Okay, speak of more theoretical thinking also sometimes. Okay, but most of the problem, what you have to touch in the exam. Okay, those are what you call. I mean, you should not touch the problem which is very lengthy in the exam. I mean, leaving those things apart. Okay, so most of the problem, I mean, they will be giving something, everything needed for the question that is, sorry, needed to get into answer that will be there in the question. Okay, and you need to read the question, given quantity, you need to attain whatever they ask. Okay, that should be very simple. Okay, most of the problem. Let me pick some of the problem here. Am I audible on Google Meet? Huh. So you may have some confusion with this one. One type of question they asked about time evolution, then orthogonality with the initial state. Am I right? Find time evolution. Find the time after which it is orthogonal to initial state like that. Take time evolved state. Okay. Take initial state. Take orthogonality and all. Okay. This is bit different. This question is bit different. Okay. So other 2 to 3 question I think CSR net just questions. Okay, speak up. So they are asking time evolved, after that orthogonality, but this is bit different. Am I right? Two state quantum system with energy plus or minus E corresponds to normalized state psi plus or minus. Okay, so the system at t equal to 0. So can I write like this? I mean, I'll write psi at t equal to 0. I'll write capital psi because I don't use ket notation. Okay, 1 by root 2. Speak up. What is this one? Psi plus psi minus. Okay, this is with energy E plus. This is with, I mean, plus E. This is with energy minus E. Okay, speak up. The probability that system will be in the same state at t equal to h by 6e. Okay, speak up. Let us see. First, we need to find time evolution. Am I right? I mean, so he's talking about some later time. Means this is at t equal to 0. So this is at t greater than 0. Am I right? Pick up. How do you do? 1 by root 2. Psi plus e power minus I plus e t by h bar plus psi minus, okay, e power minus I of minus e. Am I right? Speak up. Psi minus with energy minus e. That will this will be plus I e t by h bar. Okay, speak up. Now you find, okay, probability that system will be in the same state at t equal to this one. Am I right? At t equal to h by 6e, you have done the measurement, isn't it? And he's asking some probability. Let me discuss that one. Okay, so now let me find psi at t is equal to h by 6e. H by 6e. So 1 by root 2, okay, psi plus e power h by h is h by 2 pi. 2 pi will come into numerator. Minus I 2 pi by 6 t. T. Sorry, t is only substituted. T is only substituted. Okay, plus psi minus e power plus I 2 pi by 6. Check this out. Will you get this one? Now, at this time, you have done the measurement. What is the probability of getting this state back? Okay. Now, the question, whenever we do the measurement, we got either psi plus or psi minus. Am I right? Why he is asking probability of getting linear combination state? Isn't it? So, you will understand in the spin idea. Okay. In spin, this may be linear combination state of some operator. Okay. Speaker. But that may be eigenstate of some other operator. Is that okay? This looks here. In case of energy, it's a linear combination of energy eigenstate. Okay. In spin, what will happen is energy eigenstates can be, okay, which is a linear combination of energy eigenstate. That can be one of the spin state actually, Sx, Sy, Sz. Okay, I mean that is possible actually in the spin. I mean whenever you see this plus or minus E energy, you can link it with spin related problem. Am I right? I mean, when spin of particle placed in external magnetic field, it will possess plus or minus E energy. Am I right? Pick up. So I mean, it is related to spin only. That's why it is possible. Okay, pick up. So at t equal to this one, okay, you are doing the measurement. That means this is state before measurement. He's asking, okay, probability of getting the initial state. Okay, speak up. So probability of getting, speak up, psi at t equal to 0. Can I say this is state after measurement? What do you say? Probability of getting this state after time t equal to h by 6e. That means you have done the measurement on the system after time t equal to h by 6e. You're asking what is the probability of getting the initial state, that is this state, same state. Is that okay? Speak up. Is that okay? So this is state before measurement. This is a state after measurement. Am I right? If you're asking probability of getting this one means, I mean, you have to assume that you have done the measurement, you got this outcome. Inner product mod square. Isn't it? Pick up. What is this one? Psi at t equal to 0 after measurement. Okay. The star. Okay. Psi at t equal to h by 6e dx. Isn't it? Mod square. Mod square. Now, what are these? Can you any way to get pi by 3, pi by 3? Am I right? Can I write directly pi by 3 here? Pi by 3. I think some sine or cos would come. Okay, you better to do that one. Don't substitute. Do that one. Cos or sine would come. I am guessing. Am I right? No. Speak up. So now this integral is full range of interest. Okay, integral is full range of interest. That's why. So that integral is equal to. Okay, I'll do this integral here. What is this one? 1 by root 2. Okay, psi plus star plus 1 by root 2 psi minus star. State what you call after measurement, that is initial state. Okay, initial state means with respect to time, that is initial state. This is a state after the measurement because he is asking probability of getting this state. Am I right? That should be state after the measurement, isn't it? Speak up. So now multiplied with 1 by root 2 psi plus e power minus I 5 by 3 plus 1 by root 2 psi minus e power plus I pi by 3. Okay, dx here. Okay, I mean later we shall do with direct notation. Okay, now let us convert it like this. Okay, speak up. Now that is equal to, now look at here, whatever this e power, okay, psi plus psi minus multiplied integrated, that's 0. Whatever coefficient, it will come out of the integral. They are orthogonal, isn't it? Speak up. Only among these 4 terms, only 2 terms will remain. What is this one? Psi plus psi minus psi minus. Isn't it? Pick up 1 by root 2, 1 by root 2, 1 by 2. Okay. Integral mod psi plus square dx. Okay. What will come outside? E power. Sorry. E power minus I pi by 3 will come outside. This one, this will come outside. Okay. Plus 1 by 2 e power plus I pi by 3 will come outside. Psi minus psi minus. What is this one? Integral mod of psi minus square dx. He mentioned they are orthonormal, I think. Okay. Speak up. So this is equal to e power minus I pi by 3 plus e power I pi by 3 divided by 2. Am I right? So cos pi by 3 1 by 1 by 2. 1 by 2 is not the answer. Mod square. This is inner product. Okay. They may give that is one of the answer. Speak up. Mod of 1 by 2 square, that's equal to 1 by 4. You have 0.25 answer. Is that okay? This may be a bit what you call confusing question for you. Anyone who asked this question? Deepak, are you there? Somebody sent a solution. Yeah. I mean, if you guys have discussed, that's good. Okay. But what I'm saying is it is possible. Right now, in this chapter, whenever we did the measurement, we asked one of the eigenstate actually. Okay. But that can be eigenstate of some other operator. If you do that operator measurement, okay, this linear combination state, it looks like linear combination state, it may be eigenstate of some other thing. Okay, some other observable. Okay, that's what I'm saying. Okay. So after time evolution, what is the probability of getting the state back? Okay, this state. Okay, that means this should be state after the measurement. Okay, this should be state before the measurement. Is that okay? Inner product mod square. Speak up. Any question? Whenever they give the state, okay, if they mention that it is normalized, then also you better to check whether it is normalized or not. Sometimes questions were wrong actually. They mentioned that it is normalized, but it was not normalized. Some typing mistake were there. Okay, speak up. But in this question, they didn't mention that it is normalized. It's a linear combination state containing infinitely many terms. Am I right? Harmonic oscillator. Is that okay? I will write it like this. Okay, I'll write summation over. Okay, uh, n equal to 0 to infinity 1 by root n factorial. I'll write this one as psi n. Okay, cat 10, you write it as psi n. Okay, because now we don't have practice of Dirac algebra. Okay, speak up. Or I will write like this: psi is equal to whatever. I'll write this one as capital psi. Capital psi. So that's what I use for linear combination state. N equal to 0 to infinity. Okay, speak up. 1 by root n factorial into psi n. No, you are free to multiply the total thing by a constant. Am I right? That's what I was repeating. Anyway, later you will make it as a unit vector, isn't it? I mean, normalize. Later you are going to normalize, isn't it? I mean, you can't multiply one of the term by one constant, other term by other constant. Then you are changing the weightage of the term or direction of the vector. I hope I gave enough idea. Okay, the whole thing can be multiplied with a constant. You find this multiplicative constant a in such a way that this total state is normalized, where the psi n are normalized. Am I right? He mentioned n is normalized energy eigenstate. Okay, speak up. So since psi n are normalized, okay, how do you normalize this one? Speak up. Psi, I mean, you have to consider summation over n equal to 0 to infinity a by root n factorial psi n. You have to treat it like Cn into psi n. Am I right? If psi n are normalized, how do you normalize this linear combination state? Pick up summation over mod Cn square equal to 1. You have to do the derivation, how these two are equivalent. Then only you will remember. In Griffiths, he has done, am I right? How this is equivalent to integral way of normalizing this one, isn't it? Speak up. Now, this is equal to, speak up, summation over mod a square into n factorial, n equal to 0 to infinity, okay, is equal to 1. Am I right? We better to spend one class on that series convergence and Taylor series, power series, and all. Okay, there are some very simple question, and that is required in almost all problems, many problems. Am I right? Pick up this Taylor series and all, Taylor series, power series, and all. Okay, pick up. Now this is equal to, look at here, mod a square outside summation over n equal to 0 to infinity 1 by n factorial is equal to 1. What is this? Now this comes in e power x expansion. Am I right? What is e power x? 1 plus x square by 2 factorial plus x cube by 3 factorial. How do you write in a summation? Summation over x power n by n factorial, n start with 0. If you put x equal to 1, you'll get 1 by n factorial summation. Isn't it? I mean, these ideas are required. Okay, speak up. I mean, especially in just exam, they design many questions. Okay, speak up. So that's why mod a square. What is this one? E power 1 is, okay, summation over n equal to 0 to infinity 1 by n factorial, isn't it? 1 power n by n factorial. Okay, this is E is equal to 1. Okay, that's why A is equal to 1 by root E. So now you got normalized state. Okay, speak up. I mean, to do any probabilistic stuff for any average value, you have to first normalize. Am I right? Speak up. Then what is asking? Expectation value of Hamiltonian, average energy. Okay, speak up. Average energy is a harmonic oscillator problem. Okay, speak up. Now normalized state is, okay. Now what is this one? Summation over 1 by root E, okay, into 1 by root n factorial into psi n. Am I right? N equal to 0 to infinity. This is Cn now. Okay, speak up. Now what is average energy? Summation over mod Cn square into En. Okay, En equal to 0 to infinity. Okay, if you can't apply this simple formula, that means you haven't done the homework. Okay, speak up. I mean, I hope you are matured enough to evaluate yourself. Pick up. En equal to 0 to infinity. What is mod Cn square? 1 by E into n factorial. Am I right? Into En plus half h bar omega. Okay. Here you may need a bit idea. You may quickly think what is that one of the summation. Am I right? 1 by E outside, h bar omega outside. Okay. H bar omega outside. Okay. One of the summation is n by n factorial. Okay. Other summation is, okay, half outside, summation over 1 by n factorial. This one you know. This one is same as earlier. Can I write like this? That okay? This one is again e power 1. Okay? Pick up. What is this one? Okay? So now when you see this one, okay, n by n factorial. Okay? I mean, this one, summation over n equal to 0 to infinity n by n factorial. First term is 0. Am I right? Speak up. First term is 0. So that's why, or if you write like this, suppose n equal to 0 to infinity, uh, n divided by n into n minus 1 factorial. Speak up. What is this one? Summation over. I mean, in this one, first term is of no use actually.
We can simply expand. We'll again get.
Again we can simply expand. I mean, we'll get that one. I mean, 0. Okay, first term, second term, 1 by 1 factorial plus 2 by 2 factorial plus 3 by 3 factorial plus 4 by 4 factorial plus and so on. There are infinitely many terms. Okay, this term is 1. What is the second term? That's also 1. I mean, 2. I mean, if I write denominator as 2 into 1 factorial, okay, this will be 1 by 1 factorial. Okay, denominator I'll write 3 into 2 factorial. Okay, speak up. 3 got cancelled. That will be 1 by 2 factorial. Here denominator I will write 4 into 3 factorial. 1 by 3 factorial plus and so on. What is this one? E only. Am I right? E power 1 only. Speak up. So this one happened to be the same as this one. Okay, speak up. Any other way to argue? This summation is same as that summation. I'm thinking when you write n divided by n factorial, I'll start with n equal to 1 to infinity. What do you say? Because anyway, n equal to 0 is not giving any factor, isn't it? Speak up. So then I'll write n equal to 1 to infinity. I'll write 1 by n minus 1 factorial. What do you say? N, no, n divided by n into n minus 1 factorial. N got cancelled. No, I mean, just check this out. What I'm trying to prove here, n equal to 1 to infinity, 1 by n minus 1 factorial. Okay, this is equal to summation over n equal to 0 to infinity, 1 by n factorial. Am I right? Here n start with 1, but you have n minus 1. That's equivalent to n start with 0, you have n. Why not? Or n minus 1 plus 1. I'll start n with one step lower. I will increase n by n plus 1. What do you say? That is same as earlier. I mean, I have taken capital N here. Or I'll do like this. Okay. Summation over n equal to 0 to infinity 1 by n plus 1 minus 1 factorial. That's what I'm saying. I have started n equal to n start with n or n equal to 1. I kept n was there. Now I'm starting n equal to 0, but I'll place n plus 1. Is that okay? Speak up. That again becomes E. Okay, speak up. So what will happen? H bar omega by E. This is E half of E. E plus half E. What is this one? 3 by 2 E. Isn't it? 3 by 2 H bar omega. 3 by 2 H bar omega. Oh, that happened to be first excited state energy. Average energy usually was not any eigenstate. Am I right? So Hamiltonian, I mean, expectation value of Hamiltonian expressed as half alpha H bar omega. What is the value of alpha? Okay, 3. So the idea should be generated in the place, okay, in that place, okay. That's what I'm saying, okay. I mean, suppose until now you have done, now you don't know what is this summation. Then what would you do? Now look at it. If you write some step, you will realize, am I right? You write one more step, you will realize what is that summation equal to, isn't it? Speak up. I mean, if you suppose if you left the question here, that is a very big loss, am I right? Look at here. When you write that one, it is same as this one, okay? Speak up. So that's why. Or actually, one of the student, what he has done is he calculated that one for many values. He took very large number. I mean, because calculator was allowed. He calculated that summation actually, and he took larger and larger number. Anyway, very higher values can be neglected actually, and he wrote the nearest answer. I mean, you should not give it up. That's what I'm saying. Okay. I mean, when there is any possibility of doing the problem, is that okay? Speak up. Yeah. Shall I move on? I hope this question you can answer. You have to watch all of those videos. Okay. Speak up. I explained a lot of things. Half harmonic oscillator. We call this one as famous half harmonic oscillator. We shall solve this one ideally, okay, in WKB method. Okay, we shall find energy eigenvalue of this one in WKB method. Right now, I mean, we don't want to solve Schrodinger equation for this one. Okay, logical answer. Okay, speak up. I mean, one side infinity. Am I right? Other side harmonic oscillator potential. Isn't it? Now you take your full harmonic oscillator. In the full harmonic oscillator, you pick the state, okay, whose wave function goes to 0 at x equal to 0. I mean, here, look at here. Potential is infinity means particle is not entering to this region. Particle is not entering to this region means wave function is 0. Wave function is 0 in this region means continuity of the wave function requires that wave function should be 0 at x equal to 0. Are you getting point? Pick up all of your wave function, okay? Pick up. They should start with 0 only here. They should be 0 when x is less than 0. They should start with 0 here. Okay, speak up. All of your wave function, okay? Psi n or something, okay? Speak up. So psi n of 0 should be 0. So because when x is less than 0, okay, this psi n equal to 0 because particle cannot enter that region. You take full harmonic oscillator. In the full harmonic oscillator, you pick the state whose wave function is 0 at x equal to 0. What are those state? Not ground state. Ground state is Gaussian, which is not going 0 at x equal to 0. First exact state. N equal to 1 state. Am I right? Then n equal to, not n equal to 2 state. Am I right? N equal to 3 state. Odd number state, odd quantum number state. Can I say like this? Figure. So that's why when you see the options, look at it here. These two options are nonsense. Why? wave function is discontinuous. It will never be discontinuous. Hmm? These two options are possible. Okay, what he is asking, let us see. Which one of the following represent possible ground state? Ground state means for this one, what is the minimum first state? That is n equal to 1 state. Am I right? Pick up. That n equal to 1 state looks like this. I mean, for full harmonic oscillator, it is like this. Am I right? But half harmonic oscillator, it is 0 here. Okay, it is like this here. Any question on this one? Speak up. Anyone on Google Meet? This may be higher state. Am I right? No, I mean, this looks like some other function. Like it went downward again. Node you can tell, but you have to assume that this one, this doesn't have any node. Huh. No, that's a good idea. Am I right? Speak up. This is ground state. Ground state had no node. Am I right? 0 to infinity is your region of interest. No node. You can say like that. Okay, speak up. Wait a second. Let me draw ground state. Ground state is like this. Okay, speak up. Your first exact state, that means n equal to 2. Am I right? What is the ground state energy? Speak up. Can you tell me? 3 by 2. 3 by 2 h bar omega. Okay, you should know what is the energy. In one problem, I asked what is the nth energy for this one in our design MCQs. Okay, speak up. Here, what is n equal to 2? Like this. No, not like this. Maybe like this. Am I right? Isn't it? N equal to 2, 3 by 2 h bar omega, 5 by 2, 7 by 2 h bar omega. This is the ground state, first exact state of this half harmonic oscillator. Okay. Now 0, I mean, this is first exact state. Am I right? It has one node. That logic works. That logic works. Okay. I mean, 0 to infinity is our region of interest here. Okay. Speak up. Now 3 by 2 h bar omega, 7 by 2 h bar omega. I mean, how to write nth state here? Wait a second. In En is equal to n plus half. Okay. Pick up h bar omega. You have to pick n is equal to 1, 3, 5, and so on. Am I right? Now, if you want to rewrite that one, En, that's, I mean, odd n. Am I right? Can I write 2n plus 1? Okay, plus half. Okay. H bar omega. This one should start with 1. That's why n will start with 0, 1, 2, 3. What do you say? Either this one, either you quote that, speak up. Either you quote that n equal to 135, or if you want to run n from 0, you write 2n plus 1. What do you say? Or you can make 2n minus 1 also, but start n with 1. Am I right? I mean, you can 2n minus 1 is also odd number, but don't make it negative. Start n with 1. Okay, speak up. That's the difference. Okay. I mean, this one actually we see full harmonic oscillator and we restrict, we choose, we pick. Okay, but here, I mean, we want to write what you call direct, what you call energy for this one. I mean, we want to run n like integer. Okay, all integer. Okay, speak up. Speak up quickly. Oh, one of the question may take very lot of time. Okay, somebody asked this question. If anyone have solved this one, you reply to that instruction channel message with your solution. Okay, speak up. So a particle of energy E moves in one dimension under the influence of a potential. If energy is greater than V of x for some region of x, which of the following graph can represent bound state wave? Bound state means whatever we discussed, those are bound state actually. It should be normalizable solution. Okay, this is not normalizable. Wave function is discontinuous here. That's not possible.
C and D we can remove, but D, why is D not?
This D wave function is discontinuous, isn't it? Wave function is
But psi
discontinuous.
square still always.
No, it is wave function is a solution of second order differential equation. Okay, if it is discontinuous, how do you take second derivative?
Sir, in one
Okay,
case,
from the solution, if you want to go to Schrodinger equation, you take first derivative.
sir, there was one case where we did not take second derivative.
That was second. I mean, first derivative was discontinuous, not wave function itself,
Oh,
isn't it? First derivative can be discontinuous. Okay, wave function will never be discontinuous. I'll come to that point in direct delta problem. Wave function will never be discontinuous. It should always be continuous because it represents probability. Its mod square represents probability. Probability cannot suddenly change or something. Okay, that may be the basic idea. Okay, and one more thing, if this function is discontinuous, how do you take first derivative? You can't take first derivative. Second derivative again doesn't, I mean, cannot be taken actually. Okay, I mean, it is not solution of any second order differential equation. Dirac delta problem should be separated. Speaker. In Dirac delta problem, derivative will be discontinuous, but wave function is still continuous in all problem. Okay, among these two, which one you choose? I mean, this looks like this, am I right? I mean, keep on moving, oscillatory. I mean, this is normalizable, no doubt. Okay. I mean, if it is only one option, you choose this one. One option problem. This is TAFR problem, I think, isn't it? Now, it looks like these heights are increased here, but it's not so clear what will happen further. Am I right? Speak up. Actually, oscillatory function, okay, I mean, that integral, I don't think it will converge to any value. Area under the curve, it will converge to any value.
it will also be a function.
Huh?
It will also be a function.
I don't know.
Infinity.
Okay, what oscillatory function we have? Suppose sine square x, you integrate 0 to infinity or minus infinity to plus infinity. No, sine square will become anyway, you take mod square, am I right? So sorry, mod, if you take mod square, its integral is infinite, am I right? Negative will also come positive. Area under the curve will be infinite if it continues, if it is oscillator. Okay, speak up. Suppose it looks like sine square x minus infinity to plus infinity dx, that diverges. Okay, that cannot be normalized. Yeah,
How is it sine square?
I mean, this is if it is minus sine x, when you take mod square, you do mod square and then integrate in the normalization. Okay, speak up. I mean, it will come to positive part. Am I right? When you take mod square, then area under the curve positive only. I was integrating this one, not this one. Integrate mod square of this one. Okay, speak up. So that's a preferred answer. Okay, speak up. Is that right? Answer it. That's right. Okay, speak up. Now, what is the problem with this problem? When this is expectation x, okay? I mean, those who don't know the Dirac notation, okay? But this problem can be done here, okay? Whatever he's asking, that is expectation x in that linear combination state.
The solution also somebody puts. Content, they put the solution also in the channel.
Okay. Now, what I'm saying is, I think it will be C1 into C2 or something, am I right? Expectation x contains C1 into C2 or something. Okay. I mean, you take it neatly. Okay. I will use capital psi. Okay. C naught. Can I write C naught psi naught? I prefer psi naught in place of phi naught. Okay. Plus C1 psi 1. Okay. Phi naught and phi 1 are what you call orthogonal eigenstate of ground state and first excited state of one dimensional harmonic oscillator. Okay. How do you find expectation x? Okay. Speak up. You do psi star x cap psi dx. You put that operator. Ladder operator. What is this one? So that's equal to root of h bar by 2m omega. Okay, speak up. C naught star psi naught star plus C1. I mean, when I see all options, they are real. Am I right? C naught psi naught plus C1 psi 1. I mean, I'll make it simple. So A plus cap plus A minus cap operated on C naught psi naught plus C1 psi 1. This is Weichel problem asked in many exam. Okay, speak up. I mean, anyway, we are solving and I designed my question also. Okay. Now among many, I mean, only I think A plus operator on psi naught, it will become psi 1, root 1 into psi 1. That is needed because you have that psi 1 state. But A plus operator on psi 1, that will become psi 2. Psi 2 is orthogonal to both of these. Pick up. Its inner product will be 0. Okay. A minus operator on psi naught, 0. Okay. Lowest state. A minus operator on psi 1, that will become psi 0. Root 1 into psi 0. Okay. Pick up. So that's why root of h bar by 2m omega. Okay. I mean, I'll write this one. C naught psi naught plus C1 psi 1. You should have a good hold on this one. I mean, doing it quickly. Okay. Ladder operator. Okay. That will become, I think, C1. Sorry. C naught psi 1. A minus operator on this one. C1 psi naught dx. Am I right? Speak up. That's equal to root of h bar by 2m omega. Okay. Psi naught term, you take it outside. C naught C1 integral of mod psi naught square dx. Okay. Plus C naught C1 integral of mod psi 1 square dx. Okay. Pick up 2 C naught C1 because these are normalized. Okay. Pick up root of h bar by 2m omega. 2 C naught C1 if they are real. Otherwise, I think C naught star C1, C naught C1 star. That addition will remain, isn't it? Otherwise, that term will be C naught star C1 plus C naught C1 star. This term will remain, I think, if they are complex. Okay, speak up. Now, for which values of C naught and C1 this is highest? So this will give negative. Am I right? Pick up. This will give 1 by 2. This will give 3 by 4. Sorry, root 3 by 4. Which one is higher? Root 3 by 4, 1 by 4, 1 by 2. Which one is higher? 1 by 2 is higher. Then who selected this option C?
I think that
Sir, E not equal to minus C1.
Option A, C naught equal to C1 is equal to 1 by root. For this one, okay, C naught C1, C naught C1 value is 1 by 2. Okay. For this one, okay, speak up. C naught C1 value is root 3 by 4. Which one is higher? 1 by 2 is higher? Or root 3 by 4 is higher? Option A is right, okay? 1 by 2 is higher, am I right? Option A is right. Zero point 0.43. This is 0.5. Yeah. I need a kind of hold, okay? I mean, after solving the problems, okay? I mean, you should solve problem yourself so that you should have a kind of hold on the problem, okay? So I'll quickly discuss this one. So this should be plus mgx, okay? Can you change? Potential, it cannot be it cannot be minus mgx, plus mgx, am I right? A ball bounces off the earth, you asked to solve this quantum mechanically solve this problem quantum mechanically, assuming that Earth is infinitely hard sphere, considering surface of the Earth as the origin, implying potential is equal to infinity and linear elsewhere. Okay, wait a second. Let me write this one. He gave v of x like this. Okay, speak up. It's equal to infinity when x is less than 0. It's equal to mgx. Okay, when x is greater than 0, it is like this. If this is surface of the Earth, our ball cannot penetrate into Earth. Okay, this is your positive x-axis. This is your origin. If ball is anywhere here at a distance x from the origin, okay, speak up. Its potential energy is mg into x. X when x greater than 0. When x less than 0, our ball cannot penetrate into that region. Potential is infinity. Can I say like this? Speak up. Which one of the following wave function is physically admissible? Okay, you draw this potential first. Okay, speak up. So v of x, okay, as a function of x, it is linear here, it is infinite here. That means particle cannot enter here. Okay, speak up. And it should be normalizable in the, our region of interest is 0 to infinity. It should be normalizable here. Continuity of the wave function demands that again wave function is 0 in this region. Particle cannot enter. X less than 0 means inside Earth. X greater than 0 means above Earth. Is that okay? Speak up. Then particle cannot enter here. Wave function should be 0. That's why wave function should be 0 at x equal to 0. Okay? Wave function should be 0 at x equal to 0. Wave functions are not 0 at x equal to 0. Is that okay? So these two are possible. Now it should be normalizable in the region 0 to infinity. Isn't it? Speak up. So that one, look at here, this one, x e power kx. I think he gave k greater than 0. X e power kx, as x tends to infinity, it is blowing up. It's not normalizable. But this is normalizable, 0 to infinity, that exists, that integral exists. Okay? Speak up. At x equal to 0, this is 0. Perfect.
So, but how do you get this? How do you solve this equation?
This one we shall solve in variational principle, approximation method.
So can you let Taylor expand or something? Because it's unknown potential.
Which Taylor? How do you Taylor expand? You have one side infinity. That boundary condition should be taken care, isn't it? We shall solve in. We have this problem in approximation method. Okay, speak up. But which of the following wave function is physically admissible? Non-normalizable wave function are not physically realizable. Okay, that's why it should be normalizable in the region 0 to infinity. Okay, speak up. And wave function should be continuous. Whenever potential is infinity, okay, speak up. So your wave function is 0. Okay, that's why at x equal to 0, wave function should be 0. Okay, speak up. That's how I have chosen. Whatever the experience we have, apply and solve the problem. Okay, speak up. Is that okay? Now, one more problem. I will give the hint because it may be very lengthy. You guys try. I think somebody tried already. This particular problem. Have you tried this one? Particle moving in one dimension under the potential V of x such that for large positive value of x, V of x nearly equal to kx over beta. Actually, whenever this kind of problem is there, you better to apply whatever you know. What is that harmonic oscillator you know? Am I right? So where beta is 2, when beta is 2, this will be also 2. Am I right? Lambda is also 2. But that won't work here. Check this out. All options are like this. If beta equal to 2, lambda is also 2. I try to apply harmonic oscillator, which I know Gaussian is one of the wave function, e power minus x square. That won't work. And one more thing, he is expecting something else. Okay, this is the potential only for large x value. This is the wave function, isn't it? If wave function is given, we can find the potential. We had one idea, am I right? Now he is not asking potential. He is asking that beta lambda relations, isn't it? That's why what you have to do here is, while doing the problem, you have to make that approximation. You take its second derivative, okay? I mean d square psi by dx square plus v of x into psi is equal to e into psi. Okay, speak up. Plus e into psi. Okay. Now, when you take second derivative, when you write the step, am I right? So in that step, you make this approximation. Let x be very large. For large x, what happens? This v of x replaced by kx power beta. What do you say? Can you quickly find the second derivative of this one? D psi by dx. Okay, I mean psi of x is equal to e power minus x power lambda. E power minus x power lambda. Okay, into minus lambda x power lambda minus 1. Am I right? Is that okay? So d square psi by dx square, that's equal to, I better to write in terms of psi again. Am I right? That was my idea. Minus lambda x power lambda minus 1 into psi again. What do you say? Speak up. So then d square psi by dx square, that's equal to I'll minus lambda, I'll take its derivative. Okay, lambda minus 1 x power lambda minus 2 psi as it is. Okay, speak up, plus minus lambda x power lambda minus 1. Okay, d psi by dx, isn't it? D psi by dx is itself minus lambda x power lambda minus 1 psi. Is that okay? What do you say? So this is minus lambda into lambda minus 1 x power lambda minus 2 psi plus lambda square x power 2 lambda minus 2 psi. Am I right? Speak up. That's your second derivative. Minus h bar square by 2m. Okay, into second derivative. This whole thing. Anything can be taken common. Psi can be taken common. Psi can be taken common.
You can take lambda into lambda power x power lambda minus 1. It will again be
Wait a second. Minus lambda into lambda minus 1 x power lambda minus 2 plus lambda square x power 2 lambda minus 2. Okay, into psi. Am I right? Is that okay? Minus h bar square by 2m second derivative. Okay, plus v of x into psi, that's equal to e into psi. Okay, now when x is very large, what will happen to e power minus x power lambda for large positive value of x? Zero. If it becomes zero, you have to zero equal to zero. The equation turns out to be 0 equal to 0. How do you handle?
So we can take lambda into x power lambda minus 2 common. We'll get 1 by lambda.
What is here? E power x power lambda. I have to take outside, like that you are saying.
Yeah, like x power minus lambda we can take outside. Or x power lambda.
X power minus 2 you can take outside.
X power minus 2. X power minus 2. X power minus 2.
How do you write? E power lambda plus lambda minus 2. Okay. E power lambda minus 2 can be taken common. Am I right? Speak up. So minus h bar square by 2m. Okay. So what this one can be written? 1 lambda minus lambda square. So plus lambda square x power lambda x power lambda minus 2 psi plus v of x psi, that's equal to e into psi. I mean, for large x, v of x is equal to what is that? For large x, v of x is nearly equal to kx power beta. How do you do? Large x approximation, how you do? Yeah. Anyone who solved? Yes.
So I just solved it, but I didn't know the right answer. It is beta plus 2 by 2. If it is beta plus 2 by 2.
No, how? No, he has given that one, means for large positive x values. Okay. This should be this one. That means we need to apply that one. Okay, in our step. Okay. Otherwise, what is the role of this information? Isn't it? You need to apply that one. But when I take that approximation, check how you apply that approximation. When x is very large value, v of x nearly equal to what is this one? Kx power beta. When x is very large value, can I neglect this one? Can I neglect this one compared to this one? Okay, speak up. So minus h bar square by 2m speak up minus h bar square by 2m x power lambda minus 2 psi, okay, plus k x power beta psi, that's equal to e into psi. Now look at here. Here x power beta psi is there. Here x power lambda minus 2 psi is there. But here only psi is there. Can I approximate this psi as 0 compared to x power lambda minus 2 psi and x power beta psi? I mean, you have some x power into psi is there.
So how can you remove multiplicative terms?
When x is very large, when this term is very large.
You can remove this term. So you get lambda square. Yeah, lambda.
Okay, sorry. X power 2 lambda. That's right. That's right. X power x power 2 lambda. That's right. Okay. Lambda square should also be there, isn't it? Lambda square. That's right. I mean, I just neglected this part. Okay. Inside that one, I neglected this part. Okay. Now you check. Okay. E power minus, suppose x square. Okay. And x e power minus x square. As x is larger, okay, which one will go quickly to 0? This should go quickly to 0. Am I right? Speak up. So that's why in that approximation, if I make this one 0, okay, then when you compare these two, Okay, speak up. Beta should be 2 lambda minus 2. Is this answer? Hmm? Beta by 2 plus 1 is answer? Answer A. Beta by 2 plus 1. Yeah, this is beta by 2 plus 1 only, lambda. Not so clear. Can you plot and check? Okay. As x is very large, okay, which one will go faster to 0? I hope this should go faster to 0. Why? Speak up. Because it do not have multiplicative factor. This may go slowly to 0. Slower than this one. That's what I'm saying. Okay, I mean, you have here psi is equal to e power minus x power lambda. Are you getting? You have only psi here, but in these two sides, along with psi, you have some positive powers of x. Am I right? Speak up. Did he mention anything about lambda? Beta is greater than 1, he mentioned. Yeah. What you're saying?
Sir, we can just equate this. You said no, sir, that the constant term will be equal to e term and the
Okay,
epsilon
variable
will be-
term. Yeah, that was right. I forgot that one. I mean, you don't have to neglect this one. Now look at here. So, I mean, whatever variable you have, okay, that should be related to variable. Energy should be 0 here. I mean, energy 0 means, okay, I mean, you have d square psi by dx square. Okay, speak up. That's equal to what is this one? 2m by h bar square v of x minus a or e minus v of x. Which one?
X minus e.
Okay. Now this will be some function of x plus some constant. Okay, times psi again. This one, when you do this one. When you equate it to, okay, 2m by h bar square v of x minus 2m e by h bar square into psi, okay, this function goes with this one, okay, this constant goes with this one. Speak up. Now if I use that one, that idea, okay, speak up. What is my second derivative? Where I better to do here, am I right? Here only. Okay, speak up. So this is my second derivative, okay, lambda minus lambda square, okay, plus lambda square x power lambda, okay, multiplied with x power lambda minus 2 psi. This is second derivative, am I right? That's equal to 2m by h bar square v of x psi minus 2m e by h bar square psi. Okay, speak up. Now this should go with this one. This should be equal to this one. What is this one now? 0. Ground state energy, nearly 0 or something. Okay, speak up. Is that okay? That's right. This will work. Now again make that approximation. Okay, speak up for large x value. Okay. Now, yeah, I mean, we found v of x in this method only. Am I right? Isn't it? We found v of x in this method only. Okay, you write v of x. Okay, what is v? I mean, what is 2m by h bar square into v of x? Pick up. That's equal to lambda minus lambda square, okay, plus lambda square x power lambda into x power lambda minus 2. This is v of x, isn't it? According to our old idea, we found v of x here, isn't it? What do you think? Thinking? This is our v of x. That is the idea that I told here. You take second derivative, you try to take wave function outside. Whatever function part you have, that goes with V of x. Whatever constant you have, that goes with energy. Now here energy is 0. Okay, speak up. That's why I just compared these two. So my V of x is, okay, V of x is h bar square by 2m into this whole thing. Now you do that approximation. Again, this part is neglected. Is that okay? Lambda minus lambda square plus lambda square x power lambda, okay, multiplied with x power lambda minus 2, okay. So k x power beta for large x value, this can be neglected, okay, h bar square by 2m x power 2 lambda minus 2. That works. This idea works. Okay, speak up. Do it again. I think we better close. I need to take one more session. I think I have solved this one. Can you guys watch the video? Cos hyperbolic, it has a minima. Okay, that can be Taylor expanded and approximated as your linear harmonic oscillator. Okay, with some constant term, constant energy term, because it is raised actually. Cos hyperbolic function. Okay, it will be like this. I hope, isn't it? It is raised. This much energy is raised actually. Speak up. Watch the video, okay, for this one. Watch all videos, okay, because I mean, in quantum mechanics they are designing very good questions, okay. I mean, not bit straightforward, okay. Speak up. You need to practice. When you solve all exam question, I mean, suppose next time while doing revision, if you solve all of those problems without looking into any solution, or you if you have time after 2 weeks, you try these problems again. If you try all problem again, okay, without looking into solution, I think that is sufficient. You can solve most of the problem. Okay, speak up. Right now, many problem might have left here. Am I right? Speak up. While doing next time, okay, you should have a hold after 2 weeks. Just check whether how much you retain after 2 weeks. Okay, only those can be exhibited in the exam. After 2 weeks or after 1 month, how much you can do? Only those can be exhibited in exam. Is that okay? Speak up. That's why, I mean, if you have solved it right, I mean, right now, if you put effort to solve them yourself, okay, speak up. That, what you call, that time, whatever you spend, that's very, what you call, worth, okay, speak up. Is that okay? Yeah. Then, I mean, most of the problem, whatever you do in the exam hall, that should be simple problem only. I mean, simple means for you. That should be easily solvable only, okay? Yeah. Okay, we'll meet at 8:15. I need to prepare some GeoGebra plots, okay? Speak up. That Gaussian time evolution, Gaussian wave packet problem, okay? Let me show on GeoGebra, okay? Because that's too lengthy to solve. I think integral is too lengthy to solve. He gave some substitution and all. But on that problem, somewhere in the corner of TFR, they asked one question, okay? At what time uncertainty product is minimum or something, okay? Let us try to experience something, okay? Have a note on that one, okay? I'll update the homework. Any question? We'll meet at 8:15, okay? I need some time.